All right, so the purpose of this video is to see how Cramer's rule can be used to help solve a system of equations. And Cramer's rule is one of our, I guess, applications of finding determinants, because it's based on determinants. And so what you're going to do for Cramer's rule is that you're going to have an augmented matrix, right? Because when you're solving a system of equations, let's say three variables, three equations, you have your x, y, z plus actually like your coefficient, like the solution. So you have to somehow create systems of matrices that you can actually take determinants of, because you can only take determinants of square matrices. So you're going to have like x and y, z, and then some coefficient, and then you're going to have another x, a y, a z, and then coefficient of row 2, right? And then just like x3, y3, z3, coefficient. Okay. So you've got a 3x4 matrix, and you need to write it as a 3x3. So what you're going to do is you're going to do it, I guess, in 4 steps, 4 different determinants. First, you're going to find the determinant of just your square matrix, just as if there was no solutions. So you're going to find the determinant of just this much. Okay. Then what you're going to do is you're going to replace the x column, this column right here, you're going to replace that column with the solution column. And so this column right there, and that's going to create your first, or I guess your second 3x3 matrix, and I'm going to call that d sub x. So your d sub x is going to have the x column replaced with your coefficients, but then your y's are fine. So there's y1 and z1, y2 and z2, and y3 and z3. So this will be the coefficient column. Then you're going to do another matrix, but instead of the x being replaced, it'll be the y. And so we'll call that dy. And I think I said we'd call this the determinant with the x replaced. So then the next one would be the determinant with the y replaced. So now it's x1, c1, z1. It's like a code. x2, c2, z2, and x3, c3, z3. So now that second column has been replaced, and we call that the determinant with the y column replaced. And then finally, you can see where this is going. We'll replace the z column, and this will be our determinant with the z column replaced. So and you can do this for as many dimensions as you have, but we'll go up to 3x3. It will be the standard one. So c1 and then x2, y2, c2, and x3, y3, c3. Okay, so once you find those 4 determinants, your x component will be dx divided by d, wherever that value is. Your y will be dy over d, and your z variable will be dz over d, which is kind of cool. And you might say, well, yeah, you're still doing 4 determinants, so maybe not the most efficient, and you're probably right. But you think about it, it's going to be faster than row operations, so that's fine. And so then, and again, it's just good practice for determinants. So let's take a look at the first example. So solve this by using Cramer's rule. So the first thing I'm going to do is take a look at what does this look like as an augmented matrix. 1, 1, -1, 6, and then 3, -2, 1, -5, 1, 3, -2, and 14. And your first determinant is going to be your just the variables, these 3 columns right there. So that's going to be our first matrix we're going to find the determinant of. And so remember, you just repeat the 2 columns. So I can have like 1, 3, 1, 1, -2, 3, -1, 1, -2. Repeat that column. So 1, 3, 1, 1, -2, 3. And so then we go down, pick a color here, maybe pink. We go down this column, so that's 1 times -2 times -2, which is 4. 1 times 1 times 1, which is 1. -1 times 3 is -9. Minus, and we go back. So this looks like -6. This looks like 1 times 1 times 3, so that's 3. And this is -1 times -2 times 1 plus 2. So 4 plus 1, 5, minus 9, -4, minus -6 plus 5 is -1. So it looks like it's -3. So that's our D value, just the determinant. So then we do replace the middle column, this column right here, with our answer. Or the solution column, I should say. So we'll go ahead and do that one. So that is 1, now it says 6, -1 would be the matrix, 3, -5, 1, and then 1, 14, -2. So I was just writing that matrix first. Like that middle column is our solution column, 6, -5, 14, and then it's 1, 3, 1, -1, +1, -2. And then, now we'll find the determinant. So we repeat. So 1, 3, 1, and then 6, -5, and 14. So let's go down the diagonal like we did last time. Maybe I'll choose, go like this yellow color. So 1 times -5 times -2. So that will be +10. 6 times 1 times 1 is +6. And then -1 times 3 times 14 is -42. Minus 6 times 3 times -2, that's -36. 1 times 1 times 14, which is +14. And then -1 times -5 times 1, +5. So we have, what is that, -32 plus 6 would be -26, minus -36 plus 14 is -32, plus 5 would be -27. I think I made a mistake there. 16 minus 42 is -26. And then -36 plus 14 is -20. Oh, sorry. That's -22. My bad. -22 plus 5 would be -17. So, or like we're adding 17. So then -26 plus 17, which would give us -9. So then that's our dx. And then let's do the same thing. We'll replace our second column here. Oh, wow, that's actually our dy. How embarrassing. This whole time I was thinking it was our dx, and I'm noticing I replaced the second variable. So it took me a long time to figure that out. So that's dy. Now let's do dx. Oh my goodness, how awkward is this? So dx. So now I'm going to replace the x column. So -6. So 6, -5, 14. That right. So that's this column, and then 1, -2, 3, -1, 1, -2. And then we can repeat our first column again, 6, -5, 14, and then 1, -2, 3. It's a -2. Okay, so then let's do our determinant formula. So 6 times -2 times -2, that's 24. Well, I should probably pick a different color because I'm going to go into yellow, which is the background. So I guess we can do green. That's fine. So we have 24 plus 1 times 1 times 14 plus -1 times -5 times 3, which is 15, minus. Then we go backwards. So 1 times -5 times -2. So that's 10. Plus 6 times 1 times 3, which is 18. Plus -1 times -2 times 14, 28. Okay, so then 24 plus 14 would give us 38. And then 38 plus 15 would give us 53 minus 18 and 28 is 46. 56, so minus 56. So that's -3. So that's our dx, because it was the x column we had replaced. We have the dy, so let's go ahead and find the dz. Okay. So for the z column, the x column will still be the same, so it's 1, 3, 1. The y column will still be the same, 1, -2, 3. But now the z column becomes 6, -5, 14. And we repeat this column 1, 3, 1. Repeat this column 1, -2, 3. And let's do our determinant. So, oops. So we can go back. Maybe we can pick yellow again. So 1 times -2 times 14 is -28. This is a -5. This is a 54 minus, this is a 42. This is a -15. And this is a -12. So then, probably switch colors now. -28 minus 5 is -33. -33 plus 54 would be 21. And then 42 minus 12 is 30. And 30 minus 15 is 15. 21 minus 15 is 6. So our dz is 6. So when I want to actually find my value of x, it would be dx, which is over here. So it's -3 when compared to -3. My y value is -9 divided by -3. And my z value is 6 divided by -3. So then that's a solution 1, 3, -2. And, it's kind of a different way to solve a system, using Cramer's rule. And you could check 1, 3, -2. It should work in any of them. So let's check this one. Does 1, 3, -2 work there? 1, 3, -2. 1 plus 3 is 10. 3 times 3 is 10. Plus a 4, 14. Yeah, fantastic. So here's what I'd like you to do. I'd like you to go ahead and set up number 5, solve that using Cramer's rule. And then, same thing with number 6. And then what I'll do is I'll have the solutions that you could check as well. But, that way, you can try it without necessarily me leading through. Because I think sometimes when you're just listening, you're not actually thinking about, okay, doing the arithmetic, and I think you'll be more engaged if you, do that yourself. So, okay. And I apologize for the dx/dy mix up right there.